Hello, welcome to video 2 of the InVenture Challenge Arts Integration Series. In this video, I will talk about 3 important engineering psychology ideas you can teach to your students and how you can integrate the arts into one of them. The students should try to use these ideas as they work on making their prototype. The first engineering psychology idea is ergonomics. According to the Free Dictionary, ergonomics is the applied science of equipment design, as for the workplace, intended to maximize productivity by reducing operator fatigue and discomfort. Often you hear about ergonomics in terms of an ergonomic office chair. This means the chair has been designed to have good back support, is a comfortable cushion for your bottom, and is adjustable for your height. There are a few parts to making an ergonomic product. 1. You need to make sure the product is a good size for the intended audience. When you make an office chair for an adult, you should assume the adult is about 5 feet to 6 feet tall. But when you make a chair for a child, you might assume they are 3 feet tall. 2. Make sure it is light enough to be carried, or at least easy to move. You can make a heavy chair as long as it's on wheels. If it doesn't have wheels, you want to make the chair out of a light material so that it can be easy to move around your office. 3. Make sure the product is actually safe for the intended audience. This idea mostly comes in terms of adding in age restrictions. For example, small toys and plastic objects are not for babies and toddlers under 3, since they could eat those and get hurt. The second engineering psychology idea is about sticking with common expectation. If a product already exists and your students are improving upon it, keep important buttons in the same place. For example, everyone today expects the home button on a phone to be at the bottom of the phone in the middle. Some phones have an actual button, other phones simply swipe there, but the location of the button remains the same. Another example which can show that this principle can be more important in terms of safety is pedals on a car. The right pedal is the gas, the left pedal is the brake, and in a stick shift, the clutch is all the way on the left. No matter how the size and shape of the pedals may be changed, we keep the location the same. In InVenture, one of the lessons provided by Georgia Tech is about Scamper. Scamper is a method of brainstorming in which you take something that already exists and substitute, combine, adapt, modify, put to another use, eliminate, or reverse something in that product to improve upon it. If your students have decided to scamper a product for InVenture and they're not building something totally new, they should be careful to keep the important buttons of the product in the same or a very similar physical place. The third engineering psychology idea is color coding. Everyone knows green means go on a traffic light, so it makes sense to have your on button be green. Similarly, red means stop on a traffic light, so it makes sense to have your off button be red. When you're color coding, it's also important to be aware of your intended audience. People who are colorblind may not be able to see your color code, so it may be smart to also have words above, below, or on a button so that individuals with color blindness can still use the device without difficulty. Another interesting point about your intended audience is what color scheme or pattern would be most attractive. For example, to sell patriotic products, people often use the colors of the flag. How to color your product is where arts integration can come in. Color schemes are different patterns or sets of colors that go well together. There are 3 main types of color schemes: monochromatic, complementary, and analogous. Monochromatic is all of the different shades of a single color. A tint is made by adding white to the color, so it's a lighter version of the color. A tone is made by adding black, so it's a darker version of the color. This is a monochromatic picture of a virus that is made entirely from different tints and tones of green. Complementary colors are colors that are opposite from each other on the color wheel. For example, red and green, or yellow and purple, or blue and orange. An analogous color scheme has 3 to 4 colors that are similar to each other. For example, a red analogous color scheme would have red-orange, or vermilion, red, and red-purple, or magenta. When your students make their sketches and prototype, they can try to color it using the color schemes they choose. I also want to talk about sketching the prototype. In professional engineering drawing, the object is drawn from different viewpoints. It should be drawn from the top, side, and front, as well as overall 3D view. This image is a real engineering drawing of a simple object to act as an example for you. Unless you are a high school engineering teacher, don't worry too much about the particulars of what different lines mean. The point of this is to show that when your students make the sketch of their prototype, they should try to make the sketch from different viewpoints. This concept is actually very similar to perspective drawing in visual arts, but it's not quite the same. If you're interested in learning more about perspective drawing, talk to the art teacher at your school. The worksheet I've made that you can give to your students is about prototype sketching. On the first page, the students will practice drawing top, front, and side views by sketching them based on a 3D view of a Lego-like brick. On the second page, students will sketch their idea for their prototype. At the bottom is a small section for you as the teacher to leave comments and feedback about their sketch and their idea in general. As always, feel free to modify this worksheet any way you want or make your own that works better for your students. When the students' sketches are complete, depending on what their product is, they may be able to build it online using something like Tinkercad, which is a junior version of the engineering drawing software AutoCAD. This can then be 3D printed. If it's not something that can easily be modeled online, the student can use their sketch to build their product in person. I hope you enjoyed video 2 about the prototype.